With that, I'd love to get started here. I am Pierre Tessier. I run the solution architect team at Honeycomb. I am joined by two wonderful people. Michael Sickles, let him introduce himself real quickly.
Hello, everyone. I'm Michael Sickles, another solutions architect here at Honeycomb.
And somebody I've known for quite a long time, Marino Wijay from Solo.io. Marino, go ahead.
Hey, thanks, Pierre. Hey, everyone. Yeah, there's a bit of a background there. Pierre and I have known each other for almost over a decade now. So yeah, I am a developer advocate at Solo. So I kind of work with the community. I work with open source. I am out and about traveling, talking about all things application networking. And I'm excited to be here because Pierre reached out to me and said, hey, maybe we should try and get some of that observability game going with Istio. And I'm like, hey, let's absolutely do it. It took a bit to get there, but with the right folks like Michael and Christian, who's not here with us at the moment, but he's actually probably enjoying dinner right now. Without their help, we probably wouldn't have this up and running, but here we are. So
it is cool.
Yeah, thanks so much for having us.
Yeah, really. Christian, if you're watching this later on, thank you very much for your help with helping us put this together and getting it to happen. And there's a little bit of history here. I've worked with Marino at two different companies, two different paths. We crossed a few times in our career, and we seem to be bumping each other at trade shows all the time. We're very adjacent to each other in what we do, and we definitely want to work for the common goal. And that's really helping out developers get more of their applications. And there's so many different facets to all that. Whether it's understanding what's going on in your code or connecting your services together. And there's a lot of commonality between them. We hope to bring all that forward to you today. Before we get too much further along, let's talk about what is Honeycomb, really. And ultimately, we'll do the same thing back for Solo, but Honeycomb.io is an observability company. We provide solutions for developers to understand what is going on inside their applications when they're running in that magical world known as production. We really encourage people to instrument their code, to learn about the telemetry of how their code is operating. Is it doing what you expect it to do? And to add as much context as possible to your code so you can really understand that. We're going to talk about a concept we call observability. It's all over the market nowadays, but we'll definitely hear more about that as we get deeper into all this. But in a nutshell, Honeycomb provides services for developers to understand using application telemetry how their applications are running in production. Next, Marino, you want to chat a little bit about what Solo does?
Yeah, absolutely. So thanks so much for that background, Pierre. I've always been a fan of Honeycomb, and I've seen a lot of what y'all been up to over the last little while. So it's finally great to work with you and collaborate. Solo is an API management and application networking company. So let's just say you run a bunch of different services, microservices for that matter. There are elements around having to connect them together, secure them, see what's going on with them, observe them, and basically provide the best of breed of networking services for these microservices. So what that really translates to is, if you want to hop to that next slide there, Pierre. If you recall the open source world, there are a lot of different technologies that provide networking capabilities. So we can start with Envoy, which is a proxy that many of you probably have already worked with as a mechanism to basically provide connections on behalf of applications. So when you take that and mix that into the world of Kubernetes, and you try to scale that with something like Istio, you now have all of your services being able to source route, observe what's going on with the app, and even provide some deep security as needed. But to kind of complete all of this, we also recently jumped into the world of container networking through the Cilium CNI. And we wanted to create a very robust but highly capable networking platform or application networking platform. So basically, by combining all of these different technologies and producing something called the Gloo platform, there's where your microservices can run around and play, interact with each other, and we could see it all. But ultimately, Solo was derived from this concept of we need to find a way to make application networking easier for our microservices. So Edith Levine created the company back in 2017 and scaled it to where we are today to focus on a variety of different areas in the networking stack that we see today. So that's it. That's a little bit about Solo. I'll talk more about Istio because that's really where our focus is a little bit later on. Oh, yeah, I actually hid this slide, so I'm not sure why it's showing up, so that's okay. But this was just a little bit of a brief of where we are today. We're well funded, so we're honestly constantly innovating and attempting to just grow the organization, not through hiring people, but also through our partnerships. And that's why I'm here with the Honeycomb team, because there's going to be a point in time where someone comes up to us and says, hey, I need a service mesh, but I also need to be able to see things deeply. And a service mesh gives me this data, but it doesn't provide a very nice way to look at it. So here we are with Honeycomb and different capabilities that it can provide as a platform. The company itself will continue to grow, and where we go, we actually recently made a massive change or innovative addition to the Istio service mesh. And what that actually translates to is we actually moved away from needing a sidecar when you decide you have workloads that don't need the sidecar. And we call this ambient mesh. So I won't spend too much time on it, but the thing is we're at the forefront of innovation when it comes to application networking. I cannot hear you, Pierre, if you're speaking.
I am so sorry about that. Similarly on partnerships as well, we're kind of in that same boat at Honeycomb. We grew ourselves. We focus on our core technology, and we're now working ourselves on other partnerships. Hence why this relationship here we're doing with Solo, when we're talking about service meshes, you're going to see a lot of functionality coming up with Honeycomb in the not too distant future. It's going to talk a lot more around this aspect and how we could help companies who have large service meshes and need observability, need to pull all that together inside of Honeycomb. Working with Solo to help get this moving as well. And with that, let's maybe talk a little bit about observability. We call them sickles, Michael, sickles?
Yep. That's me.
It's pretty hard on its own, isn't it? Like, how did we do this before? How do we actually make sure things were working in production before observability?
Yeah. So I'll talk from the application code side, and then maybe Marino, you'll be able to talk from the service mesh side of how we looked into things. But historically, you looked at metrics to see overall patterns of, is something going wrong? And then you'd probably jump to the logs for a lot of companies to really dig into the deeper, finer details, because that's where us developers put those better details. Maybe we put a request ID or maybe the status codes or error messages in our logs, but that's not always easy because you have to know how to query your logs. You have to know how to investigate a problem, and that's usually siloed and tribal knowledge from the experts at a company.
And Marina, what about from a service mesh side? How do we, is my service mesh working? How do you know?
I was double muted. So the service mesh angle is kind of interesting because when you think about networking patterns from 10 plus years ago, all of those patterns still exist today and have just been consolidated into a single system, which is the service mesh, or more specifically, the Istio service mesh. There are three key facets or areas that the service mesh really focuses in on. The traffic management capability, which is effectively, how do I get to my service? How do I route to it? What happens when I have multiple components of my service and I need to get to a specific version? And then also injecting things like, do I even allow other services to communicate with other services? Because here's the other thing, we also have to be concerned about malicious actors making their way into the environment and potentially manipulating how a service might provide a response. The other angle is the observability. So naturally inside of a Kubernetes cluster, there are ways to capture what your application is actually doing, but it's not very telling. Things like span and trace data may not be readily available, and that's why things like a service mesh exist. Service mesh itself today deploys something called a sidecar resource to every single container that you run. And what that really translates to is this sidecar is actually a proxy. It's communicating with that application and telling it, hey, I'm going to communicate on behalf of you. So whenever I receive requests directed to you, I'll answer those requests on your behalf. So you don't have to worry about what that request might be. It might be malformed for that matter, and I can address that better than you can. This way, you don't have to worry about codifying this intelligence right into your app and changing it every time your app changes. So the sidecar resource is very valuable in that it knows about all the connections coming inbound and outbound, but it also knows about the state of that application and the health of it. And so if it's not providing the right responses from, let's say, that service to another, we can capture that data and feed it somewhere. That data lives within the service mesh, but we need another platform to be able to take that data and present it to us in a way that we can actually meaningfully understand what's going on and discern if there are any issues with the way our applications are performing.
Awesome. And we're going to show how to do this better today. A little smarter as well. And while we're talking about observability, I'd like to, maybe we'll bring this one up. We hear a lot about observability, right? This thing is everywhere. It's almost like a hype right now. There's network observability, there's systems observability, there's data observability, there's DevSecOps observability. Oh my goodness, it's like everybody uses the word observability. It's a really cool marketing term. Yesterday, I seen a really nice tweet from the co-founder of Chef, Adam Jacob, who came out and said something along the lines of, y'all forgetting, where it came from. And something to note about observability is several years ago, Honeycomb, we sat down and we said, what do we do? What does Honeycomb do? We help people understand and ask any question of their data without really knowing what they're looking for first. And that is observability. It does come from systems engineering, being able to observe a system, looking at only its outputs. And part of that is very much so. To really say you have observability, you need to be able to look at your code and understand it's doing without adding any additional telemetry. You should be able to ask those questions from the existing telemetry that you have today. And that's really one of the key things here we talk about when we say observability. It's not just a dashboard of charts. That's monitoring. Observability really is asking questions, any question of your data in an exploratory fashion. So when we talk about observability, when we say it's hard on your own, we also mean you need the right tools, and not just the right tools, but the right practices in place to do that. You need to want to add the context to your telemetry so you can ask any question of your application. I don't know if Sickles or Marino, if you have anything else to add to this one here, but
yeah, I'd love to also probe a little bit into the monitoring side of things, right? Because a lot of monitoring companies are starting to use the same terminology. They're just saying observability, right? In fact, you kind of alluded to this, Pierre, but other companies, not even in the application monitoring space, are also using observability, right? Data observability and network observability and that data pipeline observability. But when you look at the core of it, they talk about the three pillars of metrics, traces, and logs. But if you have a metric, inherently, that's aggregated information. Like you can't unpack a metric and ask arbitrary questions about it. It's already lost its core data that caused that roll up, right? So maybe you might have a metric for latency, but you want to say, okay, well, what about my individual users? And in those more traditional monitoring platforms, the only way to start doing that is going to be maybe having custom metrics, but you definitely can't have a custom metric per user. It would blow up your costs insanely in those tools. And just their platforms really weren't built for that, right? Whereas a little bit of bias here, in comes Honeycomb, we have a purpose-built data store, and that's kind of what it takes to be able to do observability, right? You need a custom data store to have that flexibility to ask the arbitrary questions. So, and you'll probably see this when we do the demo a little bit later today, you can slice and dice by any arbitrary dimension you want, and you should be performant at scale, and you're going to be able to ask a question and then probe and ask another question, a follow-up question, without having to worry about, did I do this right ahead of time?
The one thing I just want to add there is back in my sysops days or sysadmin days, we had all of these tools that were scattered all over the place. And you would have to sit there and stitch what was going on. And that becomes very challenging, right? So think about it. I had Wireshark, I had Nagios, I had MRTG, I had some sort of logging server, and you're literally hopping through each one of these systems to try and figure out what the heck's going on and why, you know, parts of the network are not operating or operational and not accessible for whatever reason. So it becomes very challenging. But now, you know, we're in 2022. A lot of this data is just readily available to us. And it really comes down to the choice of platform we use that allows us to just take all of this data and unify it, look at it as, you know, one single stream and say, hey, this is probably the most logical way I can figure out what is actually going on without having to hop through multiple systems. And it's not just about monitoring, right? You know, to your point, it's looking at that log data, seeing what that log data is telling us, and then using that as, I guess, investigative tools to be able to figure out, okay, maybe I need to start looking at my tracing data. But all of that probably is going to be presented in one single platform through Honeycomb, right?
Exactly. That's the that's the dream. Being able to provide you the tools you need with one interface. Really is what it comes down to. You know, another part that's kind of key to making this happen is getting the data in, amalgamating the data, making sure the data is in a format that works cross-platform. There's this cool technology you may have heard of coming out around this. Sickles, you want to talk about the OpenTelemetry here a little bit?
Yeah, OpenTelemetry is a vendor agnostic way to instrument your applications. And so OpenTelemetry provides you agents and SDKs to hook into your application code. But it's more than that. They also provide a format to structure your metric tracing and log data. So as we see it, it's not just the app level. It can also be done at like the service mesh level, right? And the reason it came up is there was competing standards. So there used to be open tracing and open census, Jaeger and Zipkin, you know, had their competing formats. Honeycomb actually had its own proprietary format as well for tracing. And when you have all these competing formats as a company, if you ever want to switch, right, kind of sucks. And then you don't have to go, okay, well, I have to rip all this out of my code or I have to rip it out of my system. And if you're going to a proprietary like tool, you're gonna have to use their agents or, you know, this company is going to be using one way and then you go to another company, they're using another way. Basically, the community came together and said, hey, we should have one standard to rule them all, and that's OpenTelemetry. And legitimately, there's this XKCD out there, right, of like, hey, there's these 14 competing standards, let's create another one. Like, and then now there's 15 competing standards. Well, legitimately, though, if you look at open census and open tracing on their page, if you go there, deprecated in place of OpenTelemetry. Jaeger is getting rid of their, you know, Jaeger format and now saying you're going to use OTLP, which is the OpenTelemetry line protocol format for tracing. And then Honeycomb as a tool. Of course, we're going to be able to accept your OpenTelemetry data as well.
You know, the thing is, though, is it hard, right? Like I don't know how many times I say, hey, we want you to use OpenTelemetry. Somebody says, oh, that's hard. It's hard to use. Why would I want to use OpenTelemetry if it's hard?
Yeah, and I think that's a misconception. I think that OpenTelemetry used to be hard. When I started here at Honeycomb, OpenTelemetry was lacking in the docs department. This is before tracing was even GA'd. In order to figure out how to use the SDKs and how to even, you know, start spans, stop spans, add attributes, you'd go digging into the source repositories to try to figure out what to do. Not a great experience. And so it was confusing. Over time, though, like today, I think they've really addressed that. In fact, Honeycomb's own product managers and engineers, you know, they contribute to OpenTelemetry, and docs was a huge one. And we've made a lot of changes to the docs to make it a little bit more clear and concise. If you need to know how to do something for any given language, just go to the OpenTelemetry docs, go click on tracing instrumentation. Now pick your language and it's going to have, hey, this is how you do all the things with examples. So it's gotten a lot better. And then, of course, OpenTelemetry offers automatic instrumentation, right? So depending on the language, like Java, it's just an agent, just like any other vendor out there that you would use that you attach to the JVM. Or if you're using Node.js, it's just a package that you include at the start of your application, and it'll give you automatic insights You'll be able to trace your applications for commonly used libraries. So HTTP calls, database calls, queues, data, like, et cetera, right? So that's going to be automatically done for you. And so you really only have to worry about adding in those extra contextual details, like maybe a user ID, right? Like now it's just one line of code that you add to grab your user ID variable and add it to the span.
That makes things easy, right? Because with documentation comes adoption. That's the idea, right? Developers don't like writing docs, but quite frankly, the other developers need those docs, especially when it's developer tooling. So yes, docs, and more docs and examples always help. And the OpenTelemetry ecosystem is absolutely booming here. There's even stuff that's going to be coming out just before KubeCon, a full-fledged demo, piecing together all the parts of OpenTelemetry, covering all the feature sets with examples and match standards on how to use it. So definitely making it easy. It is this, the word becoming should be X'd out there. When it comes to telemetry, it is the standard now. And we should all be adopting it and taking advantage of what a standard does for us as well. And now we've got kind of, okay, we understand we need observability. We understand how to get the data in there. This whole entire thing about service meshes, though, what do you get with Istio? Or, like, why do I care, really?
Yeah, so thanks for bringing this up, because this kind of goes back to how we handle networking inside of the world of Kubernetes. If you just spun up a single cluster, right, at a very basic level, you could spin up a workload, communicate with it. But once you start to scale, once you start to have various parts of your application comprised of different microservices that need to call on each other, having to layer in API management individually for each one becomes quite cumbersome. Like, you could actually use an API gateway and service all of that, but you have to think about east-west traffic versus north-south traffic. So let's start with an API gateway for a second. It's the front door of being able to access your application. But what it's actually doing is it's going to accept that request on behalf of your application and say, is this request valid? Where is it coming from? Is it even authorized? Now, if that request is authorized, great, we'll let you in, we'll provide you a response, and you'll have your results shortly. That might be just a web page that you're trying to access. But here's where it gets kind of tricky, right? On the inside, right, the API gateway doesn't really know how these services are communicating amongst each other, whether or not they're securely communicating or even talking to each other using some form of authorization or authentication. Because the API gateway isn't in line with traffic. If we look at like traditional networking, a firewall traditionally isn't in line of a subnet. It actually just sits at the border of it and then accepts inbound and outbound or ingress or egress traffic. And that's all it does. But where Istio or the Istio service mesh really shines is the fact that it's able to address east-west traffic. When you have all of these different pods communicating with each other, sure, they could do so freely without any sort of identity or authorization, but that becomes very risky. So when you layer in Istio as a service mesh, that sidecar I mentioned earlier on is effectively responsible for that. There's a whole certificate lifecycle process that Istio, the control plane itself, issues out certificates out to these sidecars. So this way, you know who that identity of that application is, and you can authorize it appropriately based off of any sort of policies you layer in. Now, as an extension of that, I did mention that that sidecar resource has a lot of that observability built into it, meaning you could, if you decided today, hey, I want to see how my traffic is flowing at a layer 3 level, you could probably use something like TCP dump to figure that out. But it's not really telling you details about that request, the response request and the request flow from the client all the way to the server and what the response looks like. Not only that, in the world of TCP and below, we have sequencing that goes on, right? I'm able to, send a flow of packets and order them correctly. And I know that all of these packets are connected together in a single stream. How do I do that when I'm using HTTP and forming responses and requests? So there's something interesting that Istio does provide, and it provides telemetry for traces and spans out of the box. And it could do so either using Jaeger or Zipkin format. But why this becomes important is if you have a request flow, there's going to be something called the B3 header ID that actually tells you, this entire request flow, this entire trace is made up of all these different spans. And all of these different spans are effectively the different services that need to communicate to each other in order for you to get that response you want. So I might have 5 different services in line to get that response before I can actually see that response. So service A needs to talk to service B, needs to talk to service C, D, and then finally E, and then I get my response. But how do I capture that? That's that B3 header information. How do I visualize that? So there is a tool called Kiali that can help you see some of this. Gives you a visual representation of all the services that are talking to each other. There's another tool called Jaeger, which actually allows you to see your request flow and all the different services that have been communicated inside. The problem with these tools is that they don't operate very well at scale. If you're running something like production-based, you're not going to be able to see all of this very easily if you decided to hop into every one of these systems. So that's why, when we show that demo, you're going to see the value of the Honeycomb platform. If you can flip to the other slide, I'm going to show you.
I before I get into that, you started off talking about the east-west traffic.
Yeah.
And making sure that you know who you're getting it from. It's really hot nowadays, especially with we live in a very cloud-like world and everybody's trying to break in everything and hackers everywhere. It's this thing we call zero trust networks. They're really important nowadays, especially when you are going all over the map. For what I'm hearing, this is like, I need Istio, or Istio is going to definitely help me out with this.
Well, that's just it, right? Istio is the perfect footprint to allow you for that zero trust network. But here's the other thing you have to consider, right? It's entirely up to you how you build that security posture too, because of all the different requirements you need for your applications. So it takes some tuning. I mean, you can't just turn it on and expect everything to be locked down. And then you start to realize like, okay, I can't access anything anymore, much like how a firewall operates. But visually, like if you want to flip to that next slide here, where it gets very interesting is when you have various different requirements. So for example, you might have to rate limit certain services because you don't want to overload them with requests coming inbound. A sidecar is perfect for doing this. You may want to operate multiple clusters where Istio is running, and so you can aggregate all of this data, all of this telemetry and observability data, and bring it into a singular platform. The challenge, though, is deploying Istio for every cluster. While it's easy enough to do, tying all of these clusters together is not easy because there's this element of trust, right? I have cluster A needing to trust all the resources in cluster B, vice versa, and cluster C. So this is where something called Gloo Mesh comes in, Solo's Gloo Mesh, which actually simplifies a lot of these different activities. It streamlines the activity of the trust between different clusters. If you're running, let's say, a local Kubernetes cluster plus one on, in the cloud, plus maybe somewhere else at the edge, it's a mechanism to consolidate this so that you can use this single entry point, issue a single set of CRDs or custom resources, configure them, and that gets pushed out to Istio versus having to log into every single cluster and configure your Istio. But beyond this, right, there's extensive telemetry that you get with something like Gloo Mesh. And it makes it even easier for an integration for something like Honeycomb down the line. On top of that, there are other things that you might be after. From a traffic management standpoint, you have all of these different services that need to know about each other. Istio naturally within a cluster will give you that service discovery. Gloo Mesh across all these clusters gives you pretty much that DNS-like functionality, but at a grander level. So it's a very versatile, very highly capable application networking platform. But to simply put it, it's giving you application networking through telemetry, through observability, through security, and even through that traffic management. But when you extend it, right, if you're using open source Istio, it's fine. But when you're trying to do this in production, that's where Gloo Mesh shines.
Awesome. And it's probably, now that we know what Istio does, what observability does, why you need them together, I think we should see it in action. Because Absolutely. It really is kind of easy to make this happen, I think. I want to say it is. With that, I'm going to flip it over to you. I think, Sickles, you're going to grab this and you're going to show it off, right?
Yes, I will share my screen, and Marino and I think we'll tag team the demo portion here. Just making sure I'm sharing the right screen because I have too many. this looks like the right one. You should be seeing a GitHub repo right now.
Exactly.
So I'm going to give a little bit of prep here and talking about how we get tracing, why it matters, like in terms of, like Marino already mentioned, right? This Zipkin format. And I kind of alluded to this earlier, right? Zipkin and Jaeger with open census and open tracing were kind of the before times. So Istio is not yet adopted OpenTelemetry, but I wouldn't be surprised if that's coming soon. One of the specification pieces of OpenTelemetry, though, is the ability to support certain tracing formats and change how you do propagation of those said tracing formats in OpenTelemetry. So there's the OpenTelemetry format, OTLP, but there's also like this Zipkin B3 header, right? OpenTelemetry uses W3C for its headers. Zipkin is B3, and Jaeger probably is open tracing something. The key thing is with the, say, OpenTelemetry collector, and even at the apps, you can change which header you're using. And so you'll be able to receive this Zipkin data through an OpenTelemetry collector to be able then to translate it to OpenTelemetry format to go off to your tool of choice, hopefully Honeycomb, right? And so when we talk about setting this up, it does require an OpenTelemetry collector to receive that Zipkin format. Okay. Marino, did you want to talk about any of this setup here, or do you want me to walk through it?
Yeah. Let me quickly run through it. So for everyone that's here on the chat or in the webinar here, feel free to go to the solo COP repo and check this out. Link here, we can even drop it into the chat there. But effectively, this is the quickest way you can get OpenTelemetry with Istio up and running. In a nutshell, you'll need a pretty recent version of Kubernetes. So any one of your Kubernetes cloud providers can give that to you, GKE, Civo Cloud, EKS, whatever it might be for you. And then what you're going to go ahead and do is actually deploy the OpenTelemetry collector. The OpenTelemetry collector is actually collecting all of that data from our sidecars, and then basically is in turn feeding that back into the Honeycomb platform. But there are a few things that you need to do. So there is a OpenTelemetry values file that you'll use when you actually deploy OpenTelemetry with Helm. And there are a few things that get called out. The Honeycomb endpoint where all of this data is being stored, and an API key for authorization, which I obviously didn't share mine because I don't want you all to copy and paste, but you'll have to come in and change that. But once you have that configured, you can use this particular Helm, this file with Helm, and go out to configure the OpenTelemetry collector. That's the first part. Once you have that up and online, there's also a Helm file which provides a configuration to deploy Istio, the Istio control plane, as well as the Istio Ingress gateway, and even provide some configurations to allow Istio to send its Zipkin telemetry data over to the OpenTelemetry collector, as you can see right there that Sickles is highlighting. Now, you don't necessarily have to use a Helm file, but it was one of the easiest ways to get this all up and running. The only other thing you'll need is the Helm file binary, which I've attached a link to as well. But once you just run the Helm, actually, if you go back to the README, once you run the Helm file --debug sync, that actually will go on to deploy the Istio service mesh into your local Kubernetes cluster or wherever you've deployed it. I will point out you do need access to a load balancer or a way to expose the Istio Ingress gateway, either through a node port or something along those lines, because guess what? You're going to need to access that application somehow. So once you have Istio deployed, the next following set of lines actually deploys a sample application called a book info application. In fact, any application will do as long as it's got a front end that you want to access through a web page. The only thing you'll probably need to tune is the gateway resource that Istio provides. And that gateway resource is simply an instruction to tell the Istio Ingress gateway what ports to listen in on and for what host you're listening to. So let's just say I'm trying to go to bookinfo.com on port 8080. This is where I'm listening. This is what it gets translated to on the Kubernetes side. And then just a few other components really just to capture that URL altogether. We're just basically outputting the load balancer IP and the port that we use to access the application. And we're just doing tests so that we can actually access the application. But this right here is all that you need to get up and online with OTel and Istio. you obviously will need access to the Honeycomb platform, which I'm sure Sickles and Pierre can hook you up with right afterwards. But Istio is easily and freely available. It's open source, and there's nothing proprietary here.
Yep. Key things in here, call outs. This right here is important. You want to make sure we use the Istio gateway for our application, right? So this is putting it there.
Yeah, let me add that one point here. So that line that says kubectl label namespace default Istio -injection equals enabled. What that actually does is when you label a namespace, any namespace for that matter, this tells Istio or Istio-D, the control plane, to inject the sidecar. So if you don't have a namespace with this label, the sidecar won't get injected and it won't be service mesh enabled. Once you do turn on this label, sidecars get injected to all new workloads that get spun up in the namespace. If you have existing workloads that existed in the namespace before this label was applied, they won't get the sidecar yet. You would have to roll out the deployment or the pods themselves for the sidecar to get deployed. But you need that in order to deploy the sidecar resource and be able to capture that telemetry data.
Perfect. And so, yeah, the pieces down here are all about just testing how to be able to make sure it's working and generate data that will eventually, in this case, go to Honeycomb, right? And so you can get the actual gateway service. You can do what you need to do, put it in front of a load balancer. What I actually did is I just port forwarded it from our EKS cluster to my local machine. So I just do it locally. And so what you end up now is with this nice booking app for the example, right? So I can refresh this a couple of times. I'm going to start generating load. Maybe I want to sign in, ABC, right? And I can start doing different interactions. And now we can see what's going on in Honeycomb. So I'm going to go ahead and run the query here. So we can see that we're starting to get data here. And so this is Honeycomb. Let's talk a little bit about the Honeycomb interface. You can ask arbitrary questions. And here I've done a very simple question. I said, grab me the duration of everything that is going on across all my data sets in my solo environment, in this case for this demo. You're going to have a data set per different service. So you can see in here, we have this details service, product page service, rating service, review service. The actual Istio ingressway itself is its own service. And maybe I want to, let's just ask an arbitrary question. I'm going to group by name. Name is the interactions. And so right away, if I go to this results tab, we can see the different interactions that happen. So hitting that product page or hitting the login and log out, right? So those are the different things that are happening. And let's go ahead. Maybe I'll just focus in on this one. Sorry about that. No, not muted. I have a toddler who burst in there for a moment. I had to say, please. So yeah, anyways, if I want to look at this, just this product page, right? Now I have the specific distributions. I might go to the Honeycomb traces tab and I can maybe open up one of these traces. So hey, let's just pick up this one. This is a trace. This started off at the product page for the ingressway, right? And then we went through the actual application itself, the product page here. We can see that it served the, slash, just the index of it, and then the details. But then, there's some other things it did in here. It had to grab the reviews from our review service and then ratings from our ratings service. This is all purely Istio. There is no application tracing here at all. This is purely Istio from that enabling tracing. But we can already see some interesting patterns, right? If I want to see what took up the longest amount of time here, I can see that it was probably down on this review service, right? And we can see how that is broken up into smaller pieces.
I was wondering if you could show them that B3 header somewhere here.
I don't think the B3 header gets shown in here. Let's see. We do have the tracing information, right? And the trace ID is like the B3 header is a composite of the trace ID, the span ID, and maybe one other thing.
The parent.
If you were to, I don't think it passes parent. I think it's just traced in span, because it's saying this is going to be your parent when it passes downstream, right? So like if we have a downstream application and we have these two pieces of information here, I can see that header and I can say, hey, there's a trace header. I'm going to say I'm part of that same trace because I can see that. And now my trace ID is going to be that trace ID. And then I can see that the span ID, that should be my parent's ID. So we can build this hierarchy, A called B called C, product called details called reviews. And then I'll generate my own span ID to send downstream to the other services that I call. And that's kind of how we're able to build a trace in any tool, even, not just Honeycomb. We can also see here component proxy, because it was a proxy, right? So actually some of these, let's see, I come in here. I don't know if these all have the proxy component. Yeah, they all have proxy component because this is all going through the gateway. If you were to instrument your application, as well as having this layer, we would see this broken into even smaller parts, the app code tracing itself, and it would be glued together in the same trace as well. And we'd be able to delineate what is the portion that is hitting the proxy and which is the portion that is running through the app code after the proxy allowed it through. Anything that you want to add in, Marino, about this?
No, you actually covered it quite well. I think like what's really important is that we're seeing a request flow, right? From the moment your client is calling out to that product page and all the different services that are interacting in between, right? And one day, right, we'll probably get to see a really nice service graph on this alone so that we see how all of these different services are interacting. But from a standpoint of, I know the response times of each of these services, what could be contributing to a larger response time is probably going to be one of the most valuable metrics that I could use here, especially as, when I'm looking at it from an ops standpoint. Why is my app not performing or responding the way I expect it to? Oh, wait, this one particular service is choking because it probably doesn't have enough resources or it's receiving way too many requests. Maybe it's an opportunity to scale up, right? And that might even reform the way we operate our applications, because maybe we're implementing things like HPAs or horizontal pod autoscalers when we hit certain thresholds, right? But it's interesting. There's a lot of different directions and a lot of different valuable information we can derive from just this trace alone.
Yeah, and you alluded to maybe a service visualization. Maybe it will be sooner than we think with Honeycomb being able to do that. Hint, hint. Maybe sooner than we think that we might get something like that soon. What I know we're running up in time. We're going to open the floor to questions. Before we do that, really wanted to show and highlight one other thing. You can get individual traces in other tools. Honeycomb really does highlight that cardinality piece. If you have an observability tool, you need to be able to handle cardinality well. I just generated a whole bunch of load on my system. You can see that here, a whole bunch of requests, but we can see some of them took longer, right? What if I said, hey, what's different about these longer requests, and just selected that interesting area? Honeycomb is going to really drive home the point of what is the interesting attributes. It looks like it's this product page, or maybe, this reviews service downstream. I might be able to see the specific URL or the response size or status code. Maybe it's different versions, right? I can see this is running in US East 1B versus 1A, or maybe specific nodes or services, IP addresses, user ID. Any attribute you think is great, we should be adding it to our tracing, and that's going to be to your benefit. Okay.
Awesome. Thank you so much, Marino and Sickles, for all that. I think the key part there is what we're trying to say is it's really easy to do this. It could also be combined very easily with other existing application telemetry. So you could really pull in the service mesh with your application data. You don't have to instrument your apps to get value immediately. That's typically a barrier we see people do, saying, I need to instrument my apps before I can get more value out of Honeycomb or out of any product for that matter that does this kind of stuff. So just be aware that you don't need to do that. You could just instrument your service mesh, get started with that, and continue to iterate on that, adding more context and getting more application specific context in there. And then you have a complete picture of what's going on within your stack. Before we proceed to get into questions, I want to make sure everybody here get your I test and prod t-shirt. Because really, if you don't test and prod, what are you doing, right? Let's be real with ourselves. There is only one environment like production, and that is production. And although we want you to test your code, you should have unit tests and everything else. You really don't know how your code works until it's run in production load. So don't be scared to try things out in production. Be confident when you deploy. Release on Fridays. It's okay if you have the right tooling to ensure that you can understand what's going on if something does go sour. I'm going to sit out here for a couple more seconds, giving people a chance to kind of scan that in with their phones. I believe Bethany also dropped the link of the survey as well inside of Zoom chat, so you can go ahead and click on it from there. Go get your t-shirt. The keyword or secret word is telemetry itself. And with that, I'm gonna, any questions that you may have, that does it do this, does it do that, maybe you were hoping to see something else and we perhaps missed it. Now is your time to perhaps ask that. Go ahead and drop it in the Zoom chat if you have any. Give it a couple minutes here just in case. One question I see here that came in actually to me privately, it turns out, is will this work if your application is instrumented not using OpenTelemetry? If they wanted to add Istio with, the question is, I want to add Istio observability, but my app is not instrumented with OpenTelemetry.
Yep. The short answer is we as we kind of talk through it, this actually uses Zipkin, right, for its tracing format. The only requirement to get it to, say, Honeycomb would be to use that OpenTelemetry collector, which will take Zipkin format and translate it to OpenTelemetry. And as we saw today, right, nothing was instrumented with OpenTelemetry at the app level in the tracing you saw today. That was purely using Istio's built-in tracing module.
Awesome. Okay. I don't see any other questions coming in. Thank you so much, Marino and Sickles.
Wait.
Oh, I see one right here. What do you do if you have a lot of security compliances? We couldn't send any data externally. You know, that's a question we hear. People are perhaps weary of sending telemetry to an external vendor or to an external platform. At Honeycomb, as well as many other SaaS providers, we would be happy to work with the security team to understand what their concerns are and ensure there is tooling in place to, in fact, not send anything sensitive. I do know that the OpenTelemetry collector itself comes with a wealth of wonderful processors, including a redaction processor or a removal processor. So if you do accidentally send sensitive data, it can be scrubbed out for you at the source itself. Okay. Vladimir, we do. We would be happy to reach out to you and talk to you in greater detail about this. We have several financial institutions as well as healthcare companies that use Honeycomb today and are very satisfied. We could also sign HIPAA or BAAs, it is in the States, for those that have to oblige to HIPAA regulations. Awesome. Well, everybody, thank you so much for joining this.
Wait.
Oh,
There's one more slide, isn't there?
No.
Events.
Yes, so what's coming next? That's what I was getting at. Thank you very much for watching this. We have some workshops that are going to be coming up soon, or an academy if you want to learn more. Sign up for these. These are all free. You know, what's better than free? I don't know. It's free though. We are going to be doing an observability workshop tomorrow. If you want to learn more about just observability in general, not just Honeycomb specific, but really observability in general. Yes, we'll be a Honeycomb to show some stuff off. You can join that one tomorrow. Getting more out of OpenTelemetry with more updates. We have one next week on the 18th, as well as an advanced instrumentation workshop on the 19th of next week. That is taking the introduction to observability one step further. It's really getting into the nitty-gritty details of OpenTelemetry itself. Or if you really need to understand more about how to make your service meshes work, you need to understand more about how to get your networking, or really Istio is running you mad. You want to get on the Solo IO Academy. Definitely going to help you get on some self-paced courses to get you the information that you need to, just get more about what you need in the space. Also want to mention that KubeCon and Cloud Native Con is coming up at the end of the month. Both Honeycomb and Solo IO will be there. We'll be participating together, and we have more stuff to do. The couple of days beforehand will be several events. If you are going to be showing up to KubeCon and you're looking to do something beforehand, you can reach out to us. We'll be happy to show you some really cool community-based events, as well as what's going on at the conference itself. And with that, thank you very much to Sickles and Marino, and for everybody doing this session. If you want to know more, please reach out to us. We'll be happy to help. Till next time. Bye-bye.
Thank you, everyone. Take care.